All x's have a power of 1. What does it mean to solve the equations? Or what am I actually doing when I solve the equations?
Solving for x.
Okay, I'm solving for x, but and that's right, but we're just going to word it a little bit differently. I'm finding the value of x. Or whatever variable may be in there, which 90% of the time we're going to be talking about x. Finding the value of x. So what that means too, whenever you're asked to solve something, and a lot of teachers are a little more hardcore on this than I am, your answer has to be included in your answer. Okay, if the answer is just 7, if the answer is x plus 7 and you put 7, some teachers count that wrong. Okay? You need to make sure that if you're asked to solve, you're putting x equals or whatever equals, whatever the variable is, to the value. What do you need to consider when solving each equation? We're not going to actually write down the answer to this. Let's just kind of talk about it. What do we need to consider whenever you're solving? This has a lot of correct answers to it. Somebody from that table, back there. Big table of girls. Do what? Okay. So what step you need to do first? That kind of falls in with the SAD map. Is there anything I need to subtract or add? Table of guys at the front. Something else. Okay, what about the variable? Let's kind of expand on that. Compare compare A and B. The number of variables. Okay, I'm gonna have to. If I got 2 x's, I'm gonna have to combine them at some point. On A, it's already got. All I have is 1, so that's pretty simple. Okay, so a lot of small things. A lot of the answers I'm looking for is stuff that you probably already do. Just putting into words is kind of difficult. Okay, so let's go. Let's start on A again. Thinking SAD map here. So on A. What would be the first thing I would need to do on A? Okay, how am I going to move the 7 specifically? I'm going to add 7 to both sides. After that, Jacob, what do I need to do? And so what's my answer?
11.
X equals 11. There you go. All right, going over to B. Somebody tell me what's the first step they would do? Okay, subtract x from the right side to the left side. Is there something else I could do first and still solve it correctly?
Add 12.
I could add 12 to the left. I could subtract 8 to the right. I could subtract 6 to the... Okay, there's a lot of different first steps I could do. All right, my first step would be exactly what Jacob said. I would subtract x first from both sides. On that one, you should have ended up with -4. On C. So you got the 2 and the 4 in front of sets of parentheses. What am I going to do with the 2 and the 4? Distribute. whenever I distribute, what operation am I doing? Multiplication. So make sure you take the 2 to the m and to the 10, which I need to actually multiply. Make sure you take the 4 to the m and the negative 15. So you would need to distribute the 3, subtract 15, and is it 14? Okay, so 14 and 1/6. All right, on E, we won't get to these a lot. There's a lot of application problems where you'd end up with equations like E, but I don't think we have that for a while. But kind of like what I was saying on some of these, there's a lot of different ways to have that first step. This one, the more complicated they get, it's almost like there's even more ways to do it. And if you, for whatever reason, if you go back on Canvas and you have to look at the key to the notes, the teacher who did this problem does it completely different than I do. Okay, so if you don't like the way I do it, you can go and look at that. But you're in my class, so we're going to do it that way. Whenever you have this kind of problem, so a bunch of fractions, what I'm going to do is I'm going to find a common denominator for all 3 of them. Okay, and then I'm going to change the fractions that I need to change so they all have the same one. Between 3, 2, and 6, what would my common denominator be?
6.
Okay, so 6 is the lowest. I could do 12. Now, if I do 6, I don't have to change the last fraction. Okay, and it's the math is going to be a little bit easier. So let's go with 6. So this first fraction right here, if I want to change that 3 to a 6, I need to multiply it by what? I need to multiply it by 2. Now I've got to do the top and the bottom. So now I'm going to end up with 4x over 6. My second fraction, 2 times what is going to give me 6? 3. So I'm going to multiply the top by 3, the bottom by 3. Like we said, my last fraction is fine. Alright, the way I do this, I feel like it is the hard part of this is towards the front of the problem. Okay, it's finding the common denominator and applying it to all the fractions. Because if you have the same denominators, you can just ignore them and you make a simple equation with your numerators and you solve that. And so hopefully that one is a pretty easy one for you. 4 plus 3 is 7. Then I would divide 5 by 7. So my answer is 5/7. Questions on solving linear equations. Again, we're still kind of on just reviewing Algebra 1 stuff in here. Alright, so let's get into graphing. So talking about the different forms. So you've got your slope-intercept, you've got your point slope, and then we'll talk about the actual slope formula down there. Let's talk about each individual part of it. So we're going to identify what all the variables in our slope and our point slope formulas represent. Whenever I just have y, what does that represent? Not the y-intercept. Not the x-intercept either. Somebody's thinking that. The y variable is the... Do what? No. No. The y variable is the, talked about last time, very front of the note, very front, first page, where we had all the definitions. Okay. The y the y on here, it is representing the dependent or the output. So now that we have that defined, the x is hopefully kind of easy. The x value represents the what?
Independent variable.
Independent or the input. Alright, input and output. That's just meaning you got an equation, I give you an x value, you input that in for x, and the equation spits out a value for y. It's the output. You put something in, you get something out. The m is the what? Slope. The b is the what? Y-intercept. Okay, all of that is true with your point slope. The only thing that's different about point slope is your x1 and your y1. And I'll go ahead and give you that definition. That is any point on the line. Now, I want to talk about the names of these. I kind of emphasize that. Because a lot of people they can say the name, but they can't say the equation. Right? But if you look at the name of them, the first one, outside of the y and the x that's in there, it is the slope-intercept form. In the equation, you have the slope and the y-intercept. Point slope form, you have the slope and you have any point on the line. So they're named that way for a reason. All right? There's a lot of stuff in math that's just named by some selfish old dead mathematician who just wanted credit for it. These names have a reason. Slope-intercept has the slope and the intercept in it. Point slope has any point and the slope in it. So going down to the actual slope formula, y2 minus y1 over x2 minus x1, what does the slope represent? Or what's another word for slope? Okay, there's that, and we'll talk about that. We'll put that on there here in just a second. The slope is also your it's kind of what the line is doing in a way. Rate of change. How is it changing? How is it increasing? How is it decreasing? At what rate is it increasing? At what rate is it decreasing? What does the numerator and the denominator represent? Okay, the y2 minus y1 is the change in y. x2 minus x1 is the change in x. If you have the slope and you have to graph it, that's kind of where that rise over run comes into play, whenever you're graphing it. Or if it's graphed and you have to tell me what the slope is, you can do rise over run on the line, and okay, it's up to right 3, so my slope is 2/3. What does a graph look like if it has a negative slope? The first one or second one? Second one. Okay? From left to right, it's going down. Alright, negative slope, it's downhill. Questions on the formulas? Alright. Alright, the rest of this is mostly just examples, so now we can kind of get moving a little bit. So it says write equation using the functional notation f of x. Identify the slope, the x and y intercepts. Write the intercepts as ordered pairs. So if I'm having to find the slope and the y-intercept, what form is going to be easiest to find those two pieces of information? The slope-intercept. All right. So what is the slope-intercept again? Y equals mx plus b. Emphasis on the y equals. To get it into this, all you're doing is solving for y. So on the first one, what's the only thing I have to do? To get this y by itself, what's the only thing I have? Subtract 2x. Okay? Heard someone say subtract y. If I subtract y, now I've just moved the y over there with the plus 14, and now it's got negative, so there's even more stuff going on. If I just subtract 2x, there you go. Alright, so let's identify the two easy ones. What is the slope? -2. Okay, please don't write x whenever you're being asked for the slope. It's just the coefficient of x, so just the number in front of it. What is my, and be careful with how you give this answer, what is my y-intercept? Flip those. 0, 14. Alright, y-intercept and x-intercepts, they're actual coordinates, they're actual points on the line. So if you're asked for that, you have to give both x and y value. Okay. All y-intercepts are going to have 0 as the x value. And all x-intercepts are going to have 0 where? Okay, as the y value. So if I know that piece of information about any x-intercept, how can I find, let me throw an idea as to how we can find the x-intercept. Do what? Okay, I could graph it, but if Coach Howard's mean and says no calculators on this test. You could draw your own graph. Okay, so this y value, the y value is the output, right? Said that a minute ago. So if I know that that y value for that point is 0, I can plug 0 in for y and solve for x. Alright, if you know how to do this on a simple problem like this, solving that's probably easier than it will take less time than even putting it in your calculator, finding it, or even drawing a graph yourself. So it's going to be 7. I would subtract 14 to the left. I would divide by -2. That's going to give me 7. Going to B to get that into y-intercept would be the first thing I would do. Subtract 2x. And then do what? Divide by 4. I want you to find all the information from that equation on your own. Hopefully the slope and the y-intercept were easy to find. And then what would somebody tell me what the x-intercept would be? 16, 0. Awesome. Did anybody get something other than 16? What'd you get? Okay. So let's walk through that because that's the one. I had a few people get that yesterday. So I've got this right here, right? So you plug 0 in for y. Okay. So I would need to subtract 8. And to get rid of this, I've got to multiply it by -2. And so that -8 times -2 is going to give me positive 16. It's go down here to actually graphing these. So if I'm graphing a linear line that's in slope-intercept form, is it easier to start at the beginning of the equation or the end of the equation? At the end. Because the end has the y-intercept. The very first thing you want to be able to do is put a point on the graph. So on this first one, what is my y-intercept?
2. 0, 2.
0, 2. And then now after that, if my slope is 2, or is negative 2, you need to be able to see that as negative 2 over 1. I'm going to do my rise over run. So if it's negative 2 over 1, am I going to go up 2 or down 2? Down 2, and then would I go to the right or to the left? To the right. Let's say I did go up 2. Would I then need to go left or right? Left. Okay. And then whichever way you went, you just keep following that pattern. And whenever you have that, to find your x-intercept, you don't actually have to do the work here if it's clearly going through a point on the x-axis. So that would be 1, 0. B, it says to write the equation and then graph it. So it gives me the slope, and then it gives me the point 0, negative 2. Is that 0, negative 2 my y-intercept? Yes. So what would my equation be? I have the slope. Which is 1/3. I have my y-intercept, which is negative 2. And I can graph that. Graph my y-intercept. Mark off my slope. This isn't on here, but just a quick question. What is the domain and range of all linear lines? Negative infinity to positive infinity. Okay, so come test time, if that's on there and it's if it's a linear line, it should be easy. Okay, you wouldn't even have to look at the graph. Both are going to be negative infinity to positive infinity. Going down to C. Says write the equation that goes through that point and has a slope of negative 1. Then graph the line. So 4, negative 2, is that my y-intercept? No, so which formula do I need to use? I have a random point and I have my slope, so I would use point slope. So I've got y minus y1 equals m times x minus x1. This little situation right here turns into what? Minus a negative. Positive. So y plus 2 equals, I can distribute the negative 1, which is going to give me negative x plus 4. And then I just subtract my 2. Did Did I need to put it into slope-intercept to graph this? No. If we weren't asked to write it, I could have just gone to 4, -2. And I know my slope is -1. So I could go down 1, right 1. Last one says, find the slope of the line passing through the points 1, 9, -1, 1. Then write the equation line in slope-intercept form. So I don't have my slope, so I need to find it. What is that formula again? Somebody remind me. Awesome. So I would go -1 minus 9, -1 minus 1, -10 over -2, which gives me a slope of 5. Alright guys, these are the problems that have the most work. Here's 2 points, write me an equation. Because you got to find the slope. If neither one of those points are your y-intercept, then you have to then use point slope to get it to slope-intercept. Does it matter which point I use? 1, 9 or -1, -1? Yes or no? Does it matter? Yes or no? No, yes, no, yes? No. Somebody tell me which point they would most likely use or prefer to use. Why? Because they're positive. That's it. You don't have to deal with the negatives. A lot of mistakes happen whenever you do negatives. So I would do y minus y1 equals m, which is not m, it's 5, times x minus x1. And then simplify. So I would distribute my 5. Add 9. Alright, go to the next page. There's a multiple choice question at the top. I want you in your table to look at that and see if you can figure out which equation, none of them are in, I think they're all in standard form, which equation fits that line. That you could have done it. It might be faster, might be slower, depending on how good you are at putting it into slope-intercept form. I feel like if the equations were more complex than they are, this other way may be faster. So what you can do is take each point, or take one point, and I know at this point my x is 0, my y is 1. And what I can do is I can plug those values in for x and in for y. Okay? And if this equals 1, then answer choice A is correct. Okay? So 0, hopefully we can all agree that 6 times 1 is 1 and 0 plus 6 is 6. So that tells me that A is wrong. B starts off the exact same way and it equals 6. Okay? So that works. The only problem with this is if I come down here, zero minus 6 is -6. So that makes D true as well. If you have two answer choices that work with the same point, then you go and you check the other point. Okay? Does that make sense? It's just another way to do it. I could care less which way. If you want to do slope-intercept through all the answer choices, awesome. But if a lot of those numbers in there, instead of 1 and 6 and x not having a coefficient, if it's 1/3 and -5/7 and 9/10, just plugging in the x and y with the point, it might be a little bit easier because you can just throw all that in your calculator and check to see if that equation pans out. All right, going to go through 3 different word problems. Going to have you do the middle one on your own here in just a second. So going through 5, it says the amount of money farmers in Texas paid to maintain their crops between 91 and 08 is modeled by the equation P equals 3.53 T plus 100. P is the amount of money the farmers paid. T is the year, and 91 is that initial. Okay? What does 3.53 mean in the equation? Do what?
The dollars and cent amount.
Say it louder.
The dollars and cent amount.
3,530,000.
Okay.
Yeah.
So that's what it represents, but if it's in math terms, what is the 3.53 number? What is that? Okay, it's the slope. But in this word problem, it doesn't just mean the 3.53 million. It means the 3.53 million
It's the year.
per year. Okay? If you're ever asked to define your slope, the definition of your dependent and the definition of your independent variable are both in the definition of the slope. It's this per this. It's this every time this happens. It's okay. Both your x and y have to be in the definition of your slope. The last question is worded wrong because it talks about the farmers being paid and not paying. So how much would the farmers had paid total by 2001? So what value am I going to plug in for T? 10. Why 10?
This is 10 years between 2000.
Because of that right there. 91 being year 0. So be careful, guys. I can't tell you how many times in the past I would have a student plug in 2001 in that situation. Whenever you're talking about years, be very careful as to what you plug in for X. And somebody who's gotten the answer, what did this one come out to? 135.3 million. All right, I want you to do 6. Work as a group. To edit manuscript, Miguel charges $50 for the first 2 hours, $20 per hour after the first 2. Which of the following expresses the amount C in dollars Miguel charges if it takes him X hours to edit the manuscript, where X represents a number over 2? So which one of these would be the correct answer choice? C. Okay. On C, you got that one-time charge of $50 plus an additional 20 per hour, where X has to be greater than 2. Okay. That extra information that you don't necessarily need to be able to put that together. Okay. Coming down to 7. This one's, I think, worded a little wrong too, but I'll read it the way it'll make sense. It says a builder uses the function g defined by g of x equals 80x plus 10,000 to estimate the cost g of x in dollars to build a one-story home with a planned floor area of x square feet. If the builder estimates the cost to build a certain one-story home is 106,000, what is the planned floor area in square feet of the home? So it gives me this equation. It tells me the definitions. G of x is dollars, x is square feet. So what am I going to do with the number 106,000? Plug it in for G of x. And then solve for x. Be careful with these kind of problems, because a lot of people, they just get in the habit of here's an equation, here's a number to put in for x. Here's an equation, here's a value for x. Here's an equation, here's a value for x. Okay, probably about every 3 to 4 problems, probably 4 problems you'll come across, it'll flip it on you, and it'll give you a value for y, and then you have to do a little bit more work to find the value of x. So after this is just a simple solving with a lot bigger numbers. This is exactly the same as the very first problem you had on your notes today. The steps are exactly the same. Okay, and then 96, what does that come out to? 12,500? Correct?
That's 1,200.
Oh, just 1,200. Gotcha.